Australia's largest city, Sydney, is well known for one of its major landmarks, the Sydney Harbour Bridge. Moorefield Girls High School in New South Wales looked at ways they might be able to build a bridge on Mars.
So we're designing a Bailey bridge, and it's a truss bridge. So you basically roll the bridge. So I think it's really suitable for Mars because it's easier to carry instead of just building the whole thing. You can just roll it out.
We decided to go with a bridge because the terrain on Mars is really rough and it's hard for the Mars rovers to travel, so we designed a bridge for the Mars rovers. We went with a truss bridge as well because it's lightweight and it can resist the extreme winds of Mars because it doesn't obstruct any wind passing through.
Mainly the issue was having to minimize mass when we were transporting was very important for us, especially since the truss bridge involved a lot of bracing and a lot of different components to be able to actually move it across the other location. It was important to have to find materials and construction methods that use the least amount of tools and machinery, and having to research more into prefabrication was difficult as it's quite hard to know the conditions that might occur while we're there. So that was definitely a struggle when we were going through it.
So I learned about the material of choices, the choices of material, which one is better for compression and tension, and I learned the difference of between them. And I also learned what types of bridges are suitable for which places and stuff, I guess. Yeah, and the benefits of each types of bridges.
So we were struggling with trying to find a bridge method to be able to construct from one side, and we were searching up different construction methods of this, because a lot of them were just meeting in the middle. But the Bailey Bridge, we found that was used by the military to construct from one side when trying to get to a location where they cannot reach. So we researched into that and we saw the construction being done on rollers. So we decided to research more into rollers and different methods of moving the bridge across.
The materials we used in our bridge design was mainly steel and alloy, especially for the cords. We used alloy because it was more ductile and strong and light in weight.
Yeah, I'm pretty proud because I'm most proud of the part where I research my own stuff, because usually when we're making our example, when we're making our bridge, we kind of just follow the steps, but now I actually got to investigate myself to learn more deeper about how to build bridge and engineering stuff. So I think, yeah, I'm most proud of the material bit because that's what I did.
We used OneNote. We all inserted our own research and our planning and our sketches, so everyone had access to them. I learned how important it is for everyone to work on their own part, but also to communicate, because you've always got to check the compatibility of the design and the materials.
It helps me to learn how to work with other people and communicate better with other people.
Having to stick to a really strict schedule is important, especially when working in a team, mainly because when you're delegating work, you need to make sure that's all done before you meet up to discuss everything, and if someone's behind on the work, then it really puts the whole schedule behind. And detailed planning and recording that is really important because all team members are doing their own part, so they must be able to understand what you're recording. It's not just an individual understanding.
And I think when I go outside and work, that's definitely helped me to work better with other people.
When every team member is more passionate about our project, the collaboration is smoother and we feel more together as a group, and the end product is more satisfying.
I am really proud of it. I think the thing that I'm most proud of is communicating between the teams and like discussing the materials and like how they're suitable for this certain member, and how we were able to apply like this, learning about bridges in class.
Space agencies, they could do more testing than we could have done. So I think that was kind of something that made it more difficult and not as authentic. But in retrospect, I think the delegation and the teamwork was quite similar to what would happen in real life.
Teamwork and collaboration and design is something that I know that I'm going to be in touch with in the future, and I feel like this gave me a good segue into that kind of stuff.
I know I want to go into something in science, and considering that this project did let us research into quite a lot of different areas, I think it could help me kind of narrow down what particular specific science I would like to go into, as it gave us a good insight into not only just engineering but also like quite a lot of chemistry and earth and environmental science and aerospace science, so I think that would help.
Back in Dubai, the Winchester School further investigated the problem of building constructions, specifically bridges, on Mars.
As Mars is expected to be colonized by the year 2050, transportation on the red planet would be increasingly necessary.
Given that the terraforming measures would not be effective for another century or so, it would be rather challenging to construct transportation systems with the leniency available on Earth.
We are here today representing the Winchester School, partnering with the Moorefield Girls High School in Australia.
And so we've instigated our project to design and construct a robot, aptly called Bot, to lay down retractable bridges along the pathways that connect the future colonies of Mars.
In order to execute our goal efficiently, we split into two primary teams, design and robotics.
In design, we looked into various bridge structures, evaluating, analyzing, and finalizing on the most suitable type. We chose a cable-stayed truss bridge using chitin and iron as our main building materials after considering the rocky terrain and windy conditions of Mars.
In this process, a few difficulties arose in communication with all of our members. Few of them being confirming bridge designs with all of the teammates, along with equally considering opinions and distributing workload.
The robotics team delved into the physical and executable aspects of the project. We used a LEGO Mindstorm EV3 kit to replicate as best as we can with the limited time and resources the elements that the design team had created for the bridge layer.
And so our prototype consisted of the kit reinforced by cardboard. Now, as I said, it is designed to lay down the bridges between the colonies of Mars, and thus it would dilute the time, the cost, and the risk and physical communication among them.
Now, this opportunity has enabled us as students to traverse the vast field of STEAM. It engaged us in different elements of science and design, and ultimately encouraged learning outside our academic syllabus. This platform is such a brilliant exemplar of global citizenship, forward thinking, futuristic goals, and connection.